So I'm coming at the stream now today in 4K because I actually do have an external display now. I'm gradually getting into this work from home thing and acquiring actual things to work from home with rather than sitting at my kitchen table with a laptop. So I have a desk coming, and in order to reward myself for crossing this particular gate, I bought a gaming PC, or rather, I bought a bunch of parts. And I don't have a webcam
from scratch, huh? Oh boy.
We did go from scratch, right? And so there's always some, like, anytime anything goes wrong, which of course inevitably it will, you're like, shoot, which of these n number of parts that I got is the issue? And so I was having two distinct issues that I noticed. First is that, like, it seemed like DisplayPort wasn't working between the graphics card and my new monitor, and I was like, shoot, which of these two things is wrong, or is it the DisplayPort cable or whatever, right? I think it turns out that it just takes an inordinate amount of time when you boot a Windows PC for the signal to make it to the display.
Okay.
And
it's not fast, yeah.
It's not fast, and I got a Dell monitor, and it has one of those, like, rectangles that kind of moves across the screen. You can't even see my hands; I'm gesticulating here, but it has this one of those rectangles that moves across the screen that just has, like, a warning message on it. It was like, basically, as soon as you turn it on, it says it cannot receive a signal from any of the ports.
Mm-hmm.
So I switched to HDMI when I first was trying this out, and it was fine. So I was like, okay, maybe that was it. But I think I was just being paranoid. I think it was just this monitor.
Was it the HDMI on your motherboard versus the DisplayPort on your graphics card?
That's a good question. It was HDMI and DisplayPort both coming off the graphics card.
Both on the graphics. Interesting.
Although this motherboard I got, first of all, has lights on it, which I think is like a necessary thing. Although I was talking to my good friend James, who was actually the gentleman that got me into the game industry, and he said, I told him about this, like, ridiculous motherboard that I got and how much, like, this neon light show that I have, and he's like, oh yeah, I shop in the business section. And then he sent me a link to a motherboard that was just called, like, the Asus Pro. That was it. It wasn't like,
but yeah. I love my LED underlighting. This thing is cool.
Yeah. It is. They are very cool. The other hardware. Yeah, sorry, go ahead.
I was gonna say I did not have the fortitude to build this from scratch, so mine is a pre-built rig, and they put a button to adjust the LEDs on the outside, and I'm extremely grateful that I didn't have to figure this out myself, because it'd be driving me crazy and I still wouldn't have a gaming PC.
Yeah, and there's like, actually building a PC has gotten so much easier than the last time I tried, which was fully like 15 years ago, right? I would, like, invariably just, like, cut myself on the case, like, every single time, and now it's like the cases are even toolless, right? You can just, like, pull the pieces off and without a screwdriver. Yeah, but there's still moments where I felt like I was just gonna, like, break things. You know, I was, like, kind of plugging in a really stubborn thing or trying to pull it back out because I wasn't sure if I seated it correctly or whatever. But so anyways, I ran into this issue last night as I was trying it out, where essentially the display would go black for like 1 or 2 seconds and then come back as I was operating the computer. I was, like, playing a game or just in Windows or whatever. And I was like, again, like, oh shoot, which in the long chain of components is this? And like 90% of the time it's like a driver issue, but it's like completely opaque. It's not like you can truly fix a Windows driver issue, right? Like, you basically go to the forums and, like, yeah, just download the new drivers, and it's like, thanks, that was like my step 0. But I did find something in the forum that sounded enlightening, which was that they mentioned that, like, if your power circuit, like, in your house has too much going on, like in that full circuit, you might not have the amps for it. And I guess this person had found that, like, there was
holy shit,
there was like a mini fridge hooked up to the same surge protector, and it was causing symptoms that sounded exactly like mine. It was just like using the computer, and then like the display would just go completely black for 1 to 3 seconds. So I don't know what that is. I don't have a fridge hooked up to my Surge Protector, but I did hook the computer up to the TV, which is on a different wall in the house.
Mm-hmm.
And we played some Gears of War, me and my brother.
It was fine?
It was fine. So we'll see.
Interesting. Did you get the Xbox Game Pass, by the way, or are you doing just the
I did
monthly...
get the Game Pass.
Okay.
Yeah.
Is it worth it?
So it was $1 for the first month. And then it is $5 a month after that.
Is that it?
Yeah. It's $5 a month.
Do you have to pay for multiplayer too? Is there like a second fee?
No. It comes with Xbox Live. So $5 a month, I believe, is how much PS Plus costs, right? PS Plus is like $60 a year if you get it during the discount time.
Yes, correct.
And then you get like 189 games for free.
Yeah.
And it has like Gears of War 1 through 5. It has all the Halos.
A new Halo will probably do it for me if it comes out on PC. That's pretty cool.
Yeah. You enjoyed Destiny 2, right? You were into it for a little while at least.
I did, yeah. I think I ran out of content or Steam or forever games maybe just aren't my jam.
Yeah, I feel you.
I love Halo multiplayer though. Like, man, I played a lot of that.
Yeah. So that might be. I'm gonna switch the screen real fast so it's not just magenta. I prefer the lime green, the key lime. Anyways, so that's my adventures in new hardware, and that's why I don't have a webcam right now. Who knows when I'll have a webcam? I'll probably next stream. I'll probably just switch back to the laptop. I think 4K is worth it though. I think we like the 4K or the 60x9.
Yeah, I wonder. You could open your laptop and stream this desktop, but send me your Temple video via your laptop camera.
Oh yeah. All right. Next time we can or after stream we can experiment with it a little bit. Yeah. All right. Well, thanks for indulging me in my long spiel about my new adventure. We're both like Windows people now. We're like both fully converted. It only took a week. Right.
Man, I spent some of this weekend playing with Game Maker Studio, the game engine, and I've been doing it on my Mac, but I'm just like, no, this program wants to be on Windows, and I'm about to set it up on Windows too.
How can you tell? Is it just not like the GUI widgets aren't like the native ones, or like?
No, the whole thing is custom. It just feels like, and also like I'm pretty sure my PC is 2 or 3 times faster than my Mac now. So.
Yeah.
Yeah. Still not as good for web dev. I guess that might be it.
The CPU on your PC is a 3700?
3700 something, yeah.
X, right. I got a 3600.
Yeah, how do I find this out?
Are you on your Mac or your PC right now?
Both.
Oh.
Everything.
Yeah. Good answer.
I gotta use all the computers at once. Let's see. Hardware. Oh yeah, here we go.
Yeah.
Yeah, Ryzen 3700X.
Oh, nice. Yeah.
Love it.
So part of the deal was that my brother and I were going to build identical machines, and so we tried to set like a pretty tight budget on it. So we ended up getting 3600s, no X. It turns out to get the extra 100.
GPU did you get?
I'm sorry.
Which GPU did you get?
We got the 3600. So
the GPU.
Oh, the GPU. I'm sorry. The GPU, a 2070 Super. So I think that might be the one that you got.
I think we got the same one. Yeah.
Yeah. But I will say that my GPU, or the card rather, does not have RGB lighting on it though. Disappointingly, no part of it actually lights up. And
water cooled.
The CPU is water cooled. Yeah.
It's so weird. This whole thing is so silly.
Yeah. So if I can talk about the case, like just for a little bit longer. So the case has a glass panel in the front. I guess they all have glass panels on like in some capacity, right? But I think the point of that case is so it can show off the top of the GPU. Like it's like this gigantic card with like surface area on the top where they could like, I don't know, inlay diamonds or something like that. But unfortunately, the card that we got has no cool shit. So
that's too bad.
Yeah, it's just a shame. We just wasted our money. It's $500 right there. Yeah.
Oh my god. Yeah, we should. You should at least mine some Bitcoin to get that money back.
I have 12 hyperthreads now, just sitting there, streaming Netflix and doing nothing. So cool.
All right.
So Dom, we talked a little bit before stream about what we wanted to do. I think the general theme for today is artificial intelligence and the singularity. Yeah, we're going to make Skynet today in the next 2 hours, and
seems likely.
And then start the digital rapture. Where are you on are you team Basilisk or team anti-Basilisk?
I'm sorry.
Do you remember Roko's Basilisk from 2 or 3 years ago?
Oh man, I do. Remind me what it was again. So is it that we can't create an AI that won't kill us? So I'm going to misrepresent this because I don't think it ever quite made sense to me. But the idea is Roko's Basilisk. I don't know if the Basilisk is the AI or if it's just the name of the logical conundrum itself. Mm-hmm. I think it's the name of the conundrum because it's like so. It's a little bit like. Do you know the game? Where it's like you lose the game if you remember that you're playing the game. Do you remember that game? Yeah. Well, I just lost. Yeah.
Yes. And the second stipulation is that you have to announce out loud that you've lost the game, regardless of where you are. Right.
You just ruined a pretty good streak on that one for me. Dang.
Sorry about that, Dom. So Roko's Basilisk, similar thing. The idea is that there will it's highly likely that we are either living in a simulation now or that we will be resurrected like Buddhist style or Hindu style into a simulation in the future. And that if we do not currently live our lives out to bring about the AI rapture, then we will be simulated in sort of like a kind of like virtual hell by the AI. So the idea is like, if you just because you're even presented with this problem that I've just put in front of you, you now are faced with a mortal choice, which is either to now attempt to bring about the AI nirvana and get in the AI's good graces, or be simulated, tortured by virtual cops in the future. and apparently in the kind of like, MRA incel forums of the internet, people were got really upset that Roko, who's the username, presented this conundrum into the forum. It's like, do you realize what you've done? And they literally moderated that topic down because they were afraid of it spreading to other people.
Gosh.
So now that I've reminded you of it, are you on Team Basilisk or are you Team Anti-Basilisk? You have to decide.
I think I'm Team Anti-Basilisk.
Okay, so you're going to be tortured into infinity in the simulated future.
That's fine. I accept.
Yeah. I don't even know how I got onto this. Oh, because we're about to build an AI right now. We're about to make it right now.
Yeah. Well, we are simulating the tortured future of a bunch of our game players.
Yes. So basically, it's like Enum Team Basilisk, Anti-Basilisk.
Boom.
And then class human, name string, and then const dom equals new human dom, and then your team will be anti-basilisk. You see where I'm going here, right? We'll just set it up right now.
Absolutely, yeah. You've TypeScripted me right into hell.
Oh, and I've reset the game.
And taking us back to Magenta.
Yeah. So AI, we can go a couple of different ways. We've talked a long time about making the pilot run around the field. And the whole idea behind the pilot was to have a pilot in the tank that rolls around and can collect things and can also build things, like build a wall or something like that. The other AI that we could do, we already kind of have AI, right? The turret is a bit of AI, right?
Right. It's a very simple one that just has a single. It's like one degree motion.
Yes.
One-dimensional
and
motion.
The turret intelligence. Well, I guess it's not just the shooter; it's also the motion script of the turret here, which is actually not that complicated when you look at it. It's just like, okay, point at the player, right? It's great. I love it. So I actually think we probably won't get to this, but I think a nice goal would be to have a player that can put down a turret that can shoot at other turrets, or at least has an affiliation, a team affiliation or something like that.
I like that. Yeah.
How does that? Or the pilot guy can pick up pickups. We want to have some form of interaction in the world, right? Or we can just send the pilot guy out to a destination and have him run back to the tank. That's another.
Maybe it's yeah. How I was wondering about pathfinding in terms of AI for the pilot guy, and I like the notion that the pilot guy goes out to build the friendly turret. Leaving him in a vulnerable state and adding a little strategy to that operation. So maybe a combination of those. But let's make a little pilot guy. I wanna.
Okay, let's do pilot guy.
I wanna see someone run out of the tank. Yeah.
Okay, great. What did I do? Oh, I typed in.
You added too much AI to the code.
I added A. I added 50% of an AI.
Infinite virtual torture starts with a single letter.
Yeah. Okay, so let's do a pilot, shall we?
Yeah.
I'm gonna follow the pattern that we've been doing so far, where we just like throw stuff into the main top level game loop and then factor it out.
Let's do
it. Okay. So first of all, what's a pilot look like? Let's get him on screen. I guess we have to create a pilot, so I can't start the game loop, right? I need to make an entity that has it.
Now, is it? Do we have an existing pilot, or is it like when you click? When we send the pilot out, like the tank spawns a pilot?
I think that's probably
yeah. We still need to create it. Yeah.
Yeah.
I
think you're right. Yeah. And then probably this returns an entity, right? Oh, come on.
I know.
Did that work? Oh, I'm not returning an entity right now.
Right.
Every time the warnings surprise me.
Really?
Just because I think what it is because it doesn't surprise me. Like intellectually, I know that they're there. It just surprises me because I have fallen out of the habit of doing this every day, and so if I don't have like the constant download, then anything I'm thinking about at work is going to make me like forget it. And let me do this whole thing.
Yeah.
Thanks. Sorry, TypeScript is not my day-to-day, so it's easy for me to forget.
Oh no, man! I'm switching between TypeScript, JavaScript, and Ruby at work, so I feel you.
Yeah.
What?
I screwed up the colon and then this
arrow. Yeah.
Just because like this syntax is just ever so slightly different, right? Yeah. Okay. Yeah. Come on, TypeScript. Let's get a renderable in there, right? What does the path renderable take again? An array of and a fill style. Okay. And then I believe we have. Is it under util or math dot?
What are you looking for?
The conversion function for vec2 from values batch. This used to be called path2. I just made it a more verbose name. Yeah.
Yep. Means no more strange path2 class though.
I think that was the plan. It was just kind of like it didn't really make itself worth it. Yeah. Bring it in. Oh yeah, that's what I'm talking about.
And why did that do the right thing? Ah, come on.
I think it's because it's not relative. It's like there's no meaningful relative path because it goes up to it like percolates up to the root of the project.
Interesting. Is that the difference? Okay.
Yeah. And then we need tile size. That's the way we've been doing this right now, right?
Mm-hmm.
Oh, it did pull it in though, right? It did pull it in.
Mm-hmm. Mm-hmm.
Okay, so what do we want to make this look like, the pilot guy? I kind of want him to be a circle, actually, right?
That'd be nice. Yeah, a little circle person.
Let's make him a tiny diamond, like a tiny pickup,
okay.
And then we can make a circle later. I just didn't want to make another.
Nice.
Yeah. So the pickup.
Let's see, you probably want pickups. Nada has that diamond. It's
called Nada. That's right.
Nada.
Yeah. So you can just copy this stuff, right?
Mm-hmm.
Oh no, this is the hitbox.
Wait, yeah. Oh, you know what? I gave it a path. It takes the path from the.
Oh, of course, yes.
Model.
So where was that?
Oh,
we pass it in.
Wherever make not a pickup gets called, yeah.
Yeah. Is it entity types? Oh, yes. I copy this. I'm going to copy this whole thing.
Boom.
Well, it doesn't quite match the syntax, so. And there's a fill style in here that will. What color do you like? Orange?
Yeah. Nothing's been quite orange
tan?
yet.
Does tan exist?
Probably. I mean, is there a flesh CSS color? Let's be really. Yep. There you go.
Tan sort of exists. I was thinking of khakis. He's a pilot, so.
Oh, khakis. That's funny.
Okay. 0. How do we make them halves? We want to make them basically like a tiny diamond around the center, right?
Yeah, I think if you change 0.5 to 0.25, it'll. No, sorry, the multiplier.
X is 0. Oh, yes. 0.25. Although the X coordinate of.
Ah, right.
This is the left point of the diamond, right? That we're talking about here.
The top point of the diamond.
X is 0.
Y is up.
But the X coordinate is 0 and Y is up. Why am I getting confused by this?
I think tile size. The nice thing about the diamond is that something is always 0 on X or Y. So I think tile size times 0.25 for everything just pulls the diamond in. Right now it's extending half a tile size from the origin on each axis in each direction.
Oh, this is center oriented. Gosh.
Yeah.
Sorry, I was thinking of the origin as being the upper left corner.
Oh, no. Yeah. Not for us.
Perfect. Okay. Okay. So
I'm coming around on that.
0.25. That made it really easy, right?
Yep.
Okay. Now let's just make a guy and make sure he renders.
Let's do it. It probably needs a transform then, huh?
Yeah. Okay. All right.
Mm-hmm.
So the pilot.
We're going to call make from the pilot, right? Yeah.
Let's just grab this in a really dirty way. Dot position equals, well, it's going to be 0, 0.
Yep. It should render.
Yeah. There's a chance that there might be another entity in that spot, but let's not worry about that for now. Okay. And that should be it.
We're doing it quick and dirty here.
Okay, I do see him right there.
Yeah. Neat.
I'm going to scoot him out of the way just really quickly.
I mean, I guess since you have, it is the first entity registered, so Painter's algorithm, and it's just getting painted on top of everything else, right?
Exactly, yeah. Let's just push him up by 100 and see what happens. Okay, yeah, that's not very visible against the grass. Let's give him a different color. Maybe orange is the right call.
Orange is gonna look rough, but let's do it.
Now he's Bart Simpson. Yeah, it's still pretty rough. What do you think?
What else we got? Is anything purple yet?
Nothing's purple. Okay, it looks pretty good.
That's better.
Okay. If the pilot's going to pathfind, does he need to be able to do collision against walls, or is that going to be solved by
the pathfinding itself?
Yeah.
I guess, maybe these are like the walls that are actually giant metal spikes with like not much space between them, but a human fits through, so maybe the walls are permeable, or maybe we do have to choose to go around them. I
like the idea of the walls going around them, being able to get around the walls.
Yeah, but I kind of want to do that without the collision, because since we're not controlling the player, it should be like fully figuring its own way without having to use colliders, right?
I totally agree.
Yeah.
Okay. Okay. I'm going to create a component here. I might regret having this in a different... And all this really has is, I think, just a location. Should it be tile coordinates, or should it be pixel coordinates?
I think tile coordinates. If we're setting out to build a turret or a pickup or a wall, it'll be nice to reduce that down.
Should I call this tile pause? Was that clear?
Yeah.
Kind of naming my units in the variable, but that's okay. And then what we're going to do is on the entity, it's just our bag of stuff. And this is tucked under pilot. It's kind of weird that there's an entity namespace thing. I might bump that up a little.
Yeah, we'll sort it out. Yeah.
Okay, and then in the game, we'll just create a little system to move the player, or move the pilot rather, right? And then we'll factor it out in a second. Okay. So okay. Yeah, go ahead. Sorry.
I was gonna say the start is that the player something takes a mouse click and spawns a pilot on the player and sends it out and sends it back. Yeah.
So we could do that, and maybe for now we won't do any pathfinding at all. We'll just have them walk a linear line. Or we could work on the pathfinding.
Let's start with linear, because I think getting all that in place shouldn't take too long, and then we can actually have it walk around things.
Okay, that sounds good. All right. So it's gonna.
I definitely want turrets to aim at it when possible.
Right. We'll do it in the moving. We'll do it in moving here as well, and maybe prior to the shooters aiming, so the shooters can aim at the moved position.
Yep.
Okay. Okay, so what we're going to do is, this is the destination system. And what we're going to do is we are going to loop over all of our entities.
Oh, ID here.
Yes, thank you. Okay, and we want them to move in essentially a straight line towards the destination, right? At some velocity, right?
Yep.
Okay. And then the destination we're going to translate into real world coordinates.
Ah, right, because it's coming from a screen click.
Maybe the destination should just be precise.
Okay.
Precise world position, and then we can allow the interface to whatever's writing in here to like normalize to tile positions or something like that, right?
That makes sense. Yeah.
Okay, cool. It was complaining a bit. Okay, that's because we create one up here. That's going to be in this here.
Ah, we haven't even created one yet. Should a destination also have a starting point? Does the pilot go and come back to like the origin?
Yeah,
depends, I guess.
Let's maybe we can do a round trip next. We'll do destination. Well, like what I was thinking is that we can just have the pilot start at whatever arbitrary point that we spawned him at the beginning of the game. Have him move to a spot, get that working, and then we can worry about how to get back.
That sounds good.
Yeah. Destination. Yeah. Did I not spell this right? Oh, I got it important. Oh, Jesus. Sorry.
Nope, it's all good.
And then when we create the we start them at 100, 0. Let's make it slightly interesting. Let's go to 0, 100. So moving to the south, southwest.
Sounds good.
Okay. Okay, so we want to move towards the position. So what we want is basically some kind of scaled vector, right? This exclamation point should be necessary.
And a vec2.create here, yeah, probably.
This does not look like a legible complaint here.
Did we put destination on every entity? We did, right?
Oh, this is like a prettier thing. Sorry.
Oh, great.
Yeah. 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 What should the speed be for the player?
It's faster than our tank speed, probably.
Okay, what's the tank speed? This is a complex calculation here. 60 times tile size divided by 8. Why do we do tile size divided by 8? What does the mean? What is the significance of that? We were probably just playing with numbers, right?
Yeah, well, 60 times tile size is 1. It can move 1 tile per second. Is this 8? It can move 8 tiles per second?
Oh, I see. The 60 is just the seconds.
That's our FPS, yeah.
Yes, it's right. Okay. So that makes a reasonable amount of sense. 60 times tile size divided by 6. It's a little faster.
Mm-hmm.
And then what we're going to do is, if displacement greater than 1, this is a let. Actually, this is going to be a mat. It's not greater than 1. It's basically what I want to make sure is that that we don't move further than D, right? Magnitude D.
Haven't we done this before?
Math.max. We've done this with angles, right?
Yeah.
Is len the same thing as length? I think it is, right?
Looks like it, yeah.
Yeah. So it's basically the displacement's going to be the greater of, or the minimum of, really. The lesser of however far you're supposed to go and however far you have left to go. Does that make sense?
Yep.
And this is, yes, it's the displacement. What is the one-dimensional name of how far you can move? This displacement magnitude, basically. What I really want this to be is it's actually a vec2.scale of vec2.create of the display of the direction.
Whoa. Right. And then you just add that to the position. That's clever.
Transform. Yeah.
Disp.
Okay. We should have seen it, but he's not there.
Yeah.
Okay. So we should debug this, right? Well, let's take a really quick look to just make sure that we're reasoning about this correctly. Is it possible that I'm doing the thing where I didn't copy a vector or something like that?
Right. Is writing into e.transform safe? I feel like we've avoided this in the past, yeah.
Well, let's take a look at what other stuff does. Let's take the player mover, for example.
Yep.
It does look like the player's position just gets written directly.
That's fine then.
Yeah. Are you saying that we should have done a vec2 create here and then assign that to the position?
That doesn't seem necessary.
Yeah.
And really, we could probably do the same thing for scale instead of having disp just write to D.
So if I don't modify the position, the guy should be there, right? And he's gone.
Okay,
he's there. Yeah.
Okay, great.
But there's something about my modifying the position here that's causing this to like go to some really weird location.
maybe can we log what disp is? See where that's going?
Yeah, that's a good idea. And then I think what we also want to do is...
Also, is 100, or 0 and 100, are you underneath the player object right now?
That's definitely possible. I was expecting if the player was here, I can't draw on tuple, but oh, here I can. If the player was here, and that's 0, 100, I would have expected 100, 0 to be here-ish. Or
yeah, that's reasonable.
Or here-ish, because the origin is roughly in this area. Right?
Yeah, could it be under a pickup?
It could be under pickup, but I wouldn't have expected it to get there that quickly, right?
Yeah,
unless we had some issue. No.
So helpful.
Yeah. And then if dlen, is it GL matrix? Equals dlen 0. Well, I don't want him to keep moving if. And,
oh man, I saw it hit here for just a second.
Oh, you did?
Yeah, refresh it.
Oh yeah, it just moved super quickly.
And then disappears.
That's interesting. Okay.
Is our speed wrong?
It could be that our delta time is super high at some point. Nothing should be causing him to disappear. And the destination isn't changing, right? Yeah.
Destination isn't changing. We are...
Is this going to be visible on stream? I can bump it up a little bit.
A little higher, yeah.
Or I need to move the bottom.
Wow.
Well, this is clearly going off the rails here, right?
Wow, what is doing that? Yeah. What is our what is this showing up as? What is DT? And speed should be fine because we multiply it by DT.
Okay. Whoa.
The disp is not fine.
Yeah. So
Why is that?
What is D?
Oh man, it's like oscillating back and forth around the target.
Yeah,
increasingly large.
I was hoping to prevent that. And I did subtract them in the right order, right? It should be the... Oh, this is the target minus... It should be the position... No, the target minus position. Target minus the source should be the correct thing, right? So this one looks correct. And then let me also... Okay.
Our displacement is 0?
Yeah, that doesn't seem quite right.
D length should be...
That's
Wait, is that... Oh yeah, okay.
So the length of that vector is super huge.
Just always. And you go to the first one?
141 seems right. It's like...
Yeah.
That's like 100 times the square root of 2, right?
But that's
what we want.
The whole...
That's the whole thing. That is what we want. That is the pointer to that in that direction, right?
Wait, I see it. This should be dt times dlen, right?
Well,
no, maybe not.
Basically, I want it to go at most the full displacement. I want it to go at most the last leg of the trip.
Mm-hmm.
Right.
So what is? Can we log out dt times speed, like what it thinks it's actually doing?
Yeah. Frame step. So the first frame is 0. That's because we have no delta during the first frame, right?
Oh, so it just does
So
it?
it shouldn't just go anywhere. Yeah, it should just go nowhere. So
and it does. It returns 0, 0 as our transform.
Yeah.
But what's up with this? Yeah. Where is that coming from? Wait, we're scaling by 5. Should this actually be divide? We're taking d and we are multiplying it.
Oh, I see. So the speed is this is actually this is
I mean, it's correct, right? It's 5 pixels per frame is what it's trying to tell us.
Yeah. Oh, okay. So this is pretty basic. I think what we did is we just didn't. We have
that's divide by dt or times dt.
So it's just basically 60 times as fast as what it needs to be, right? Because we wanted to go tile size divided by 6 every single frame, right? So this should be like the frame speed. I think we just had the wrong representation. Oh, there we went. Huh. You kind of slowed down at the end?
Yeah, I saw that. Do it again.
Let me get rid of the console.logs. It's probably a little faster. My computer's a little bit chuggy right now.
Mm-hmm.
That is interesting that... Is there an... I mean, is he oscillating past it? Boy, it's not reloading right now.
You want to kill the console and sometimes that helps.
Good call.
I'm going to kill the Chrome console.
Oh, okay, yeah.
If you can.
It's, not quite responding.
Okay, I wonder if it's still... It seems like it might still be going. Oh, no, the game's playing at least. Yeah, that slowdown is weird. It really eases into that.
Yeah, it's almost as if the speed is being scaled. Because scaling D by its own, like, we don't want to do D by D len. We want to. We should be multiplying this by the normalized direction. Come on.
That looks better.
Yeah. And
now
so
I think it is 60 times tile size. Yeah.
All right, that looks correct.
That's pretty fast, but it does look great.
Okay. We don't have to make them run that quite that fast, right? We wanted them to be faster than the tank, right? How's that?
I like it.
You like it? Okay. He needs to be faster than the tank, because if the tank is driving away, he needs to be able to catch up, right?
Right, exactly.
Okay.
And maybe, I mean, like, that seems like the tank's problem.
It does seem like the tank's problem, doesn't it? Okay, so now we want him to originate from the tank, and we want him to basically be created...
like on mouse click. So we could just make it to send out infinite pilots right now.
Okay. So right click maybe is our trigger.
Ooh, do we have to turn off right? Yeah, we maybe need to turn off right click
how do we
support.
do that? Is that just a prevent default or?
Might be. We could also have it be like, could do a keyboard thing like E or something, and take the position under the cursor.
Right click is going to feel real good.
Okay.
And middle click. I think
you're right.
Yeah. So do we prevent default when the context menu is fired? Is that basically the idea?
Yep. There you go. And I guess that's where we target it. Jeez.
Okay. So maybe that's a main.js thing. Do you think?
Yeah, it feels like it. We don't want anyone to steal our source.
All right. Right click is not doing anything.
Nice.
Very cool. How are we trapping right clicks right now? What does our mouse class look like?
Does it get right click? It gets mouse down. Oh, I see.
Yeah, I'm gonna
that button from raw.
I'm gonna console, at least in the mouse ups, I'm gonna console.log the button value. Oh, this is just B. Sorry, I think my brain is still in Gears of War mode. I'm a little bit slow.
Dude, that's A-okay. So wait,
okay, that is
right
2. Click? Right click is button 2. Button 1 is the middle button?
Guess so. Do you have a middle button?
I do have. Oh, it's a scroll wheel. Yeah.
Sweet.
Okay. Okay, so we just look for button 2, right? That's basically it. Did I? Oh, yes.
Hey.
We were so good.
Nice work.
Yeah. Okay, where do we put the logic to launch the pilot? Is that just going to be in the game? We should just do it here.
Let's start there, yeah.
Okay, if the player is not dead, right? Spawn pilot. Well, the player's not dead if the game state's running, right? So
yeah, if we're in game running, we're good.
Okay, so if this mouse is down, mouse button right.
Is there colon in JavaScript? Dot, right?
I'm sorry.
No, that's cool. I wish.
PHP land.
I'd say, or Ruby. You've been writing some Ruby. Does PHP do that too?
PHP, C++ is where they got it from, I think. I think Perl probably does it too. Right? Mouse button. Probably didn't bring it in.
I see it.
Yeah, it's there. I think it's just not reloaded yet.
Weird that your file hasn't saved yet either.
Oh yeah, that is weird.
That's probably it. Yeah, it's fine.
Yeah, that was it. Okay, thanks. Okay, we need to. How are we spawning bullets right now? Or how are we aiming? I think it's like the player shooter script, right? You click left. The bullet position is the orientation. View to world space. This whole thing, right? And then mouse pause is this dot mouse dot get pause. And what does this look like? It's an option. Okay.
Cool. So unwrap. Prettier.
Yeah. It's not automatically happening right now. Isn't that weird? There we go.
And then it's
so we were going to
make and register in the entity. Yeah.
Yeah. It starts from the player position, right?
But that's the destination. You set the player position on the next line.
Oh, I see what you're saying. Yeah.
Yeah. So that's test pause. And then this .player.transform .position.
The player is also a.
Gotta unwrap it. Yep.
Yeah. I'm a victim of my own over-engineering here.
I still like it.
Yeah. And then it's going to be back to you. Copy. And format, please. I have to save twice.
That's weird.
Format.
Back to .copy probably needs first one. No way. Cool.
Okay, I'm clicking the right button right now. And
I see the
you know what? It wasn't there. Oh, it's spawning a ton of the pilots.
Why? What's happening?
It's not down. Is up.
Oh.
Well, where is that? Do we not even have that? We don't.
Great.
Whoa, I don't know what hotkey combination caused that to happen. Just a little bit of input lag right now.
Man, Tuple is really, they shipped some update that just tanks computers.
It's dragging a bit, right? Yeah.
Yeah, it happens to me every time I pair at work now too. It's really annoying.
Yeah. This.down.delete.
Send them a frowny face after the call. I will too.
Yeah. If B is not undefined. So if we do mouse up, should it have been down first? In our logic?
Yeah.
Yeah,
has
it probably
to be, right?
should have, right? Yeah.
Yeah.
If this dot down dot has B, we delete it from down and then we add it to up, right?
And how does up get cleared out?
Up gets cleared out every frame. Oh, so we need an update. That's a very excellent question. So we have the same kind of concern as
the keyboard handler.
Yeah. Okay, so we need a frame update. And let's just actually confirm that. Look at what's going on here. We have an update and we just cleared it.
There you go.
Right.
Yep.
Great. Why did that put a 0 there? That was so strange that it auto-completed that. Okay. And now the game, wherever keyboard.update occurs, the mouse needs to do the same thing.
Nice.
Yeah. Okay, so mouses now handle right clicks, I believe. So did I fix the layer? It's all here, or rather the spawning logic. Get rid of all this. If is up, right? That should do it. And that is a formatting thing. Boy, oh boy. All right, that is one pilot we're shooting out, and then we can also kill him. Let's move him way out of there, and then move at the same time so we can chase him. It's like a really slow missile, basically.
I was thinking that it's interesting in that sort of like missile artillery way.
Yeah. So there's a couple of different things that we can worry about right now. besides the fact that you can spawn infinite of them. I think that's the least of our concerns right now. One is, let's talk about walls, right?
Yep.
So we don't want to send him into a wall. So he probably should pick. You could probably need to like pick a position that is not inside a wall, which actually might force us to do a little bit of collision detection to figure out whether or not the position we target is valid.
Can we use the same raycasting we use for the turrets to like stare at where it's going, find an obstacle, and go and like pick a direction, basically?
I see what you're saying. So basically, if I was inside the wall, if the cursor's inside the wall, what should happen if I right click there?
Right.
It should go question. Like from here to there. That's problem number one. Maybe that's the less important problem. Problem number two is we want him to walk around the wall, right?
Yeah. I mean, we could also like detect if you click on a wall, we could just not send a player. We could be like, you can't, like, we see that you're clicking an object that is a collision. That's not valid.
Yep. Okay.
So I like the idea of like having the raycast go here. It targets this. So then the player maybe the AI attempts like this until it finds a clear spot, and then it like makes another beeline for its thing and sort of keeps doing that, right?
Right. So we could do collision detection in a greedy way. I apologize. This might be whiteboard time. Let me grab a USB cable. I'll be right back.
Heck yeah. I like that we already have enough primitives to make this possible, though.
I stopped plugging this in because we didn't really use the whiteboard that much in probably the last 10 streams or so. So I gotta remember how to hook this all up. What games are you playing these days?
Let's see. I've been really into City Skylines. I love a good SimCity.
Oh man, it looks really good.
It's super fun.
It looks intense, actually.
It's hard. It's really hard. And my spouse and I just played Superliminal over the last night and a half.
Tell me about Superliminal.
It really wanted to be Portal, and kind of didn't hit the mark. But it has like these moments of brilliance that are pretty cool. Wait for it to go on sale.
What is Portal like about it? Do you actually have portals?
It's one of those similar, like, you have to, like, they give you a mechanic, you have to think about it. Like, the whole now you're thinking with portals thing is like now you're thinking with like changing object perspective. It feels like it kind of just picked a very similar baseline interaction and then was like, we're gonna go to town on this. But also it tries to have a cheeky AI character.
Oh,
I know, and it really shouldn't have.
So Superliminal was that one that you're showing me where you can grab a box with like an invisible hand, and
I sent you that gif of it raycasting out to the world. Yeah. Yes,
as you move it through the world, it is essentially filling as much of the world space as the screen space that it occupies. So it kind of depends on what's behind it, right?
Correct.
If there's nothing behind it, the larger the object is. Something like that. Yeah.
Which is a really cool concept. A whole lot of cool stuff in there. Some of the puzzles were really neat. But yeah, it really, like, I think they could have spent more time on more puzzles and less on like strange AI characters.
Yeah. The cheeky AI is a really hard thing to pull off, and like I think Portal is almost the exception to the rule, right? Like it's almost like it has to be that good, or else it's gonna be really bad, right?
Right. If you do it worse than Portal, everyone will notice.
Yes.
Like, bad news. Don't try.
All right. Well, I want to hear more about that. I want to hear also more about City Skylines, but we can talk about now that I've got the iPad hooked up. We can
love it.
We can talk about pathfinding, and I also have this nice grid background too, so that's gonna help.
That's very nice.
Okay, so we had. Oh, my sister's asked me for how much sourdough we want. I'll let Bunny answer that question. Oh, I think I'm in black. I'm drawing black on black.
Oh, there's a problem.
Yeah.
Hey. All right.
So we had some issue like this, right?
Mm-hmm.
So the tank is here, and the click, let's say, is here.
Mm-hmm.
I don't know why I'm elaborating this. This is the target.
Yep.
Okay. And you were saying, okay, maybe we cast array.
Mm-hmm.
Like that. And where we hit, we have to pick a direction at that point.
Yep.
And is the idea there that the guy will randomly choose directions? What is he going to walk along this path?
I was thinking, so basically, like, we've got this algorithm.
Mm-hmm.
We can say that, like, if we get a hit, we know we've hit like a tile-sized object. Yeah. And we could pick the next, like, we could try to hit the next tile-sized chunk and see if we go through it or not. Maybe as if we cast array from, like, I don't know, we have to, like, say, oh, if we were here, let's step over, see if we can see our object yet. No, keep stepping, keep stepping, keep stepping, keep stepping.
Yeah.
Until we get a clear line of sight. I don't know. So I guess, what kind of, is the path we want to walk, is the path this? Or is the path like this?
I think normally the way this is done is through some kind of optimizing algorithm. So it'll basically pick the minimum cost of the path based on some cost function. And the cost function in this case is really, really easy because it's just how far, like, how much distance do you cover, like, on the ground. Mm-hmm. Now, you could imagine the cost function could be different if we, for example, had terrain penalties where, like, if there was a swamp or there was a mountain or there's like a forest and it took you longer to... You good?
I can suddenly hear my PC through my headphones, so it's definitely making some... The fans are going.
Oh, that's good. What's making it go?
Probably the stream and just the fact that it's kind of warm up here.
The motherboard that we got... Sorry, I'm going back into Harbor Land. The motherboard that we got has a fan on it. Like, there's a motherboard fan. Is that a thing? Like, do all motherboards have fans nowadays?
I think they all have fans nowadays. This thing has some big chunky fans on top of that, but there definitely is one motherboard fan.
Okay, yeah. Yeah, a lot of components have fans. The motherboard has a fan. I don't think graphics cards always had fans on them, but they have fans on. They sure do now, right?
It's weird because it's like we haven't actually advanced. Technology is advanced, but, like, we've advanced it by making it hotter, bigger, and, like, louder. Like, it's not like we discovered, like, cool new graphics cards.
Yeah.
Though Apple's rendering pipeline for these new ARM chips is apparently going to just be different. Like, they've just made an entirely different set of choices. So we'll have to deep dive into that someday.
Yeah. Yeah, I actually joined the Apple Developer Program the other day, and I was thinking about trying to apply to get one of the dev kits for the Apple Silicon.
That'd be cool.
Yeah, it's doable. They just send you, like, a Mac Mini with the new stuff on it. I think that's pretty cool.
I was thinking, like, I need to replace, my personal laptop at some point, and I'm like, I'll get that.
Yeah? Like, would you be, like, a Generation 1 early adopter of the new...
Yeah, I've done it before. It usually works out pretty okay.
Yeah. Yeah.
Especially if it, like, runs Intel stuff as well as they say it does, like, it won't be a problem.
Yeah. GPUs. It's funny, when we were building this, my brother was like, so it's kind of funny how the GPU nowadays is just like a computer inside of a computer. Mm-hmm. And it's actually more that, like, nowadays your gaming PC is like, it is the GPU, and you happen to have a shittier computer around it. Right?
Yeah, I was noticing that, like, it doesn't need much RAM, it doesn't need much CPU.
Yeah.
You kind of just have to throw a GPU in there and, like, be able to feed it fast enough, and that was it.
Yeah.
It's weird.
It's going to be exciting when that becomes an issue for this game, right?
Oh, I can't wait.
Yeah, it's going to be amazing. Okay, so a greedy path is probably going to be, or like an optimal path for this guy is probably going to be something like this, or potentially something like this as well, and maybe not hugging the wall as much. And the way this is usually done is through two different algorithms that actually aren't that hard to understand. So I think it's worth talking through them.
Let's do it.
The basic one is called Dijkstra's algorithm, which you've probably heard of. And then there is one called A star, which takes a little bit more juice. Like both of these algorithms I can't recite them off the top of my head, but conceptually they make sense. A star is Dijkstra, but it has a little bit of sauce on top of it so that it doesn't make as many silly decisions that Djikstra does. And the idea behind both of them is you have to know how to subdivide the space, right? You basically need a map, and that's why having the grid is nice here. Okay, so I'm going to recreate this drawing really quickly.
Okay.
So we had something like some Tetris-looking thing here, right? And think of each of these as like occupied. And they're also no-go.
Yep.
And then you have your origin here, and then you have your destination here. Is there a way I can make that look more like a D rather than an O? And what you actually do is you basically you run a greedy algorithm. So what you do is in your first iteration, let's say that your only moves are up, down, left, and right. Although diagonal is technically possible in this game, right? So let's say we can also move diagonal, right? But the kind of moves that the path that we're actually assembling is going to be a move from here to here, or from here to here,
right?
Or from here to here, or from here to here, and then also the diagonal variants of that as well. And what we're going to do is we actually just basically like simulate a brute force search. So what you would do is you'd say in generation 1, these are your candidates, right? And you stick that into a queue. What we're basically doing is a breadth first search. Just imagine that the world is a tree, and the root of the tree is where the origin is, and its children are all the nodes, or all the tiles that are adjacent to the root. Does that make sense?
Yeah.
And those are the children of your tree, right? So it's going to look something like your origin is here, and then it's going to have, what, eight little guys popping out here. And each of these are going to be a thing, right? And they're all going to have like a bunch of stuff here.
Yep.
And the general idea behind Dijkstra is you're trying to find the shortest route to the destination. And the destination is going to be the child of an infinite number of paths in this tree coming down. So the idea here is that you do this in a breadth first fashion, so you're not just searching infinitely. If this was depth first, and you went left for your first kind of thing, you would just be searching this whole line to infinity. Right.
Exactly. And I guess once you find a path, you can discard every branch that is longer than that once you hit like some step length.
That's right. And so what you want to do is you want to just intelligently build up this tree. So you basically want to say, well, these are all generation 2.
Right. Do you avoid already trod paths? Like you don't go from one, like going to here is actually like a waste of effort.
That's a really good thing to point out, right? So that's one of the optimizations that we want to avoid. We basically, you're absolutely correct, because that technically you can make a tree where you just go left, right, left, right, left, right, left, right, and just basically infinitely stay in the same place. So you do need to actually have a memory of where you've been and avoid those things. Um, Now, so far the example that we're looking at is pretty uninteresting because basically the tree is basically going to be like radial rings of nodes outside from the origin. Where it gets a little bit more interesting though is when we start to like bump into walls.
Hmm.
So this is a little bit the raycast actually that you're talking about is not that different from the sort of curveball that A star adds to this algorithm. And I probably won't go into what that is. We can just read the Wikipedia later just to get precise about it. But notice now there's a new thing in generation 3 when we're going from generation 3 to generation 4. Actually, it's probably generation 4 that where it starts to get kind of neat.
Mm-hmm.
So what this is actually going to eventually do is it's going to fill out a ton of stuff. Like you can imagine this whole space is going to end up getting filled in with like numbers.
Mm-hmm.
And the algorithm is such that once you get to D, once you get here, you're done. Because if you pursue the algorithm in a greedy way and you do the right optimizations, you'll just get there.
Neat.
Yeah. So it's a little bit interesting. Like you can imagine in this example, if you just pursue this greedily, you just literally keep stepping out one ring at a time, you'll actually get the best path right away. It gets a little bit more interesting when there are like multiple ways to get to it that are indirect. Like imagine if this was in a maze and there was like a way to get to D a couple different ways, but it was like very, very indirect. Then you actually have to start like revising best paths that you had before, right?
Wow.
Yeah. Because you might, like this number here is, to your knowledge, you can't beat a 4-step path to get to that node from the origin, right? That's the sort of idea behind this search. But it is possible to design like obstacle courses where the first time your algorithm sees a node isn't necessarily
the fastest path there.
The fastest path there. And actually, let me take that back. I think in a map where every step from node to node is equal cost, then it is actually true that the greedy algorithm is correct. It is like the first time
you couldn't get here slower and not have seen this already, essentially.
Exactly. However, if stepping from node to node actually costs different amounts, you can imagine maybe like if your origin was here and your destination was here, and stepping from node to node was like it cost you $1 billion each time you stepped. But then stepping from here to here only cost you 1, but everything else, every other step in the entire simulation cost you $1 billion. You can actually, I think, the first time you get to here, well, let's say the steps from, well, this is where it kind of gets tricky, right? Like you have to, like I'm trying to come up with a counterexample to the like first time the algorithm gets to a point, but you still have to know when to stop, right? So there is some invariant where like when you get to you do know when you've hit the optimum, basically with Djikstra. Okay, so really briefly on the variation that Djikstra adds to A star is that you'll notice that like as we're doing this search here, we're going like indiscriminately in every single direction.
Yep.
Seems kind of silly, right? We're going in all 8 directions.
I'd want to I feel like you can maybe slice off this chunk of the search, at least initially. I assume that's part of it.
Yeah, that's exactly right. So what A star says is like, okay, well, what is the next node that we're going to like add? What is the next layer that we're going to add onto this? And what they say is like, I don't think that the cost of this 4 is the same as the cost of this 4. Like, I don't think that node, even though they're both 4 steps away from their origin, I have a hunch, I have a guess, that basically what that number says, 4, is I'm going to pick the next node with the lowest cost to search, right? But I actually think that I should deprioritize this one in the corner down here, right? This one probably seems like the one that we shouldn't do. And intuitively, why is that?
Well, we've got the easy function of like distance from destination to sort of like sort these by, basically, right?
Yes, that's exactly right. So basically, what A star says is like, well, this vector and this vector are not the same.
Yep.
And so what we're going to do is we're going to add that into the cost function. We're going to add that thing there.
Nice.
Yeah. And I think with A star, depending on how you tune the parameters, you can get into a situation where it does not actually give you the optimal path. Right? There are many paths to get there. It won't actually give you the optimal one, depending on how you tune the parameters of that. But what A star allows you to do is it allows you to say, like, look, I really don't think that we should be searching these down here. And the way that you tell their algorithm to do that is basically you need some way to adjust the ranking of these extra nodes out here, right? What is the rankings of these things? Right now, the ranking is just like literally how far from the origin it is, right? But what we want to do is mix it in with some extra juice to say that, like, yeah, no, I think we should prefer the ones up here, right? These seem a little bit more promising.
And I can imagine you could like a suboptimal algorithm, as it's hard to draw the trackpad, but like basically you could make it so that if I was trying to get to D, this might be the last path I check down here because I've exhausted like a bunch of better looking ones on the way there.
Yeah, that's exactly right. I mean, you could literally have like a tube and this being the only way to get there. Right?
Yeah, exactly.
And so you can come up with, an A star will get there and it'll find the optimal algorithm. It won't be optimal in terms of runtime.
Yep.
Right. But what's funny about this is like basically this pathfinding that we're doing, we're going to be running this more or less every frame. Unless we cache the path, which we can do.
We're going to run it every frame. Oh, because like it as a system, it just has to, like, it starts here, then it's like, oh, I'm here, better find a path again.
Yeah, I mean, it doesn't necessarily have to, but for example, we might be destroying walls, right? We might be changing the terrain as it happens. And so as long as it's cheap to do this, and it sort of relatively is cheap, well, I don't know. Depending on how much stuff is actually pathfinding, it might be a little bit gnarly.
I say let's start with recalculating, because we're at least potentially limited to like screen space as our search space.
Yes.
If we have a bunch of AI tanks seeking us out, maybe we've got some problems, but maybe we solve that differently.
Yeah. So what all this, I'm looking at this now and it just looks like scribble. It's hilarious. What it really demands is like some representation of space, right? Like we need to have some notion of what these nodes are and what the relationship is. I mentioned that kind of like an isomorphism of this is the tree.
Yep.
And when you think trees, you also think of directed acyclic graphs. We're back to blockchains, basically. Yeah. And then this is a graph, right? And so really your representation of space abstractly is just going to be a bunch of nodes and edges. Now, we actually have I think a reasonable, we can kind of like fake this representation. We don't have to necessarily create a node class, because what we can say is that like heuristically, you just don't have an edge from this point and this point if there's a wall on one of them, right? You can just say like there's no edge there. And you don't necessarily have to create that alternative representation. We might be able to iterate over the terrain layer data and just say, okay, there's clearly no edge here, so we're not going to even explore that. We're not going to add it as a node onto our tree, right? Okay, so what does that look like in terms of the code? Let's take a quick look.
I was going to say, do we have any graph imperative in JavaScript? We absolutely don't.
So yeah, I mean, we may be able to see Dijkstra's got a graph. It's very pretty. And you see here, he's got these. They've got these nodes numbered here: 1, 2, 3, 4, 5, and 6. 5 being the destination, and each of the edges have different numbers next to them. The numbers on the edges are the cost. So in this case, you can think of this almost as like the New York subway map. You know how like the New York subway map is not really a true representation of the geography of New York. It has this sort of, so that's essentially what this looks like. It's basically these are straight lines between the nodes, but maybe because you can't really go in a straight line between 1 and 6. So it actually costs a lot to go from 1 to 6, right? It's one of those things where maybe the highway is like really roundabout, or there's traffic or something like that.
Yep.
Like if Google Maps was doing this problem, it'd have to take into account like how long does it normally take from some person to go from this point to that point, even though as the crow flies, it's very short distance, right? Yeah.
Yeah, I remember this now. That's rad.
Okay, so the algorithm, though, it means that we actually need to bust out our friend the min heap or the max or heaps. Heaps, typically we use the term to talk about memory, but the reason why we use the term heap in memory is because we actually use the data structure of a heap to organize the free space, right? Or the free store. Oh, and here's a nice little, maybe I should have just like clicked on this GIF rather than just like chicken scratching this. It's
how did they get our map? That's bizarre.
Tetris, it's literally the Tetris rotation of what we were doing, right? I can blow this. I can't blow it up. That zoom was amazing, Firefox. So yeah, you can see it building that graph, right?
Yeah. Interesting.
And the blue circles there is the frontier, and the red is the stuff that they already have confidence they have the optimal path to. So not only are you solving the optimal path to your destination, you're literally solving the optimal path to like every single thing in the search space while you're doing it. There's a lot of waste to this, right? And I believe there is going to be an animation for A* as well, which will show you the contrast in its behavior. Is there a GIF? Yes, is what I'm talking about. Do you see how it's preferring?
Oh, that's clever.
Stuff. It's very much biased towards the destination, right?
Yep.
And now it's gonna like, as soon as it gets around the wall, it's like saying, "Oh yeah, I like." You can see that the extra cost function that's going directly towards the things like
that makes a lot of sense.
Yeah.
Cool. I see what you're saying about me suggesting a raycast was
yeah, it was good.
Right into that. Cool.
Yeah.
Poof. All right.
Okay. So we can maybe take a starting crack at this on stream, but it'll probably be something that we'll want to finish offline just because it's a lot of nitty-gritty here.
I think that's reasonable, yeah.
Yeah. But so we can talk a little bit about the algorithm here. I love Wikipedia pseudocode. It's always so confusing to read. So let's see if we can make sense of it. Right. We have a graph. A graph is a list of vertices, and a vertex also knows where its neighbors are. Right. What data do we have in our code? Do I have a layer? So terrain is probably not what we want, right? Because terrain doesn't have walls. Walls are entities. Is that right? So in order for us to know what walls we have to search over we have to kind of create our graph, basically.
Right.
Yeah. That's a little tricky.
Was it, it's our graph, in our search space, our graph is actually kind of what that algorithm was showing or what the GIF is showing on the Djikstra Wikipedia page, right? Our graph is known. It is a fully connected set of square nodes.
Yep.
Because we don't actually know about the entities at all until we get there. So I think it's interesting because this one is actually saying like we don't build the graph in advance. The graph is sort of a complete. The graph is like a complete graph, and the fact that there's obstacles is not known to the graph algorithm or to the graph, right?
Yeah, I guess we can kind of discover the walls as we like. I think maybe what you're saying, if I understand correctly, is that we don't necessarily have to make a structure of nodes and edges. We just, when we get to the point where we're adding a new search.
Okay. There you are. Fascinating.
Was I muted this time? This
time? Maybe.
Okay, that's fine.
Yeah, I think so.
Okay. I'm gonna. The first thing I'm gonna do after this is like watch on YouTube of you kind of saying, "Yep, right." Oh yeah, that makes sense.
Please do. Audio Hijack decided that tuple was not an application. I'm glad I have levels on my Windows screen so I could see that your levels weren't going though.
Yes.
Man.
Well, I think the first capitalistic enterprise that we should get ourselves into is to hire a sound engineer or hire a streaming expert.
I'd actually pay for that.
Whom we can exploit. Yeah. That's actually not a bad cottage industry to get into. It's like the whole streaming thing that's going on right now. Like, get somebody to be your streaming expert.
We can be someone's streaming expert. We know a lot now.
it would yeah, exactly. We'd basically be Mechanical Turk, right? We'd be very much like a content filtering farm in the Philippines or something like that.
Yeah, what you're asking for, we need a producer, an on-stream producer for ourselves.
Yeah, someone who knows the dials and knobs and faders.
How does Ninja do it? We should hire whoever Ninja has.
Do you think he probably had his own? He probably figured it out himself to start with, right?
I think so, but I'm sure he has a whole team now.
Yeah. Okay, so I'll take like 5 quick minutes to talk about the algorithm. We're probably going to like crank it out off stream, but like we're going to talk through it.
Yeah.
So what I was saying last is that this algorithm calculates not just the path to where you think you want to go, because what we're seeing here is it doesn't take a destination, right? It's actually calculating the path from the source to every other place in the entire graph, which, if you talk about the graph as the map of our game, it's literally every single tile of the game that isn't occupied by a wall, right? You're going to get basically, again, the minimum distance to each one of those positions, and also a table that describes the path that leads to that particular position, right? Or each position. Now, the way that you modify this algorithm, if you have a destination in mind, is you just stop once you process the destination. So it is a greedy algorithm in that respect, where there is a strategic point in here where you can say, like, if I get to a point where I'm looking for, I can just stop and not calculate the rest of the graph, right? Okay.
Now, is that always safe? Is it, because you could have found a roundabout way? No, I guess you've been, since you're doing breadth first, you've traversed the shortest path there. Yeah. Okay.
Yeah, there's a little bit of a jazz riff in here that addresses the issue that you just mentioned. Because I actually, whenever I read this algorithm, I have a hard time convincing myself that there isn't some curveball that it's not actually addressing. Okay, so real quick, cranking through this. We have a notion of a priority queue. The idea of a priority queue basically is that, like, stuff we stick into it has some rank, and it is efficient to pull out the lowest or highest rank thing that we stuck in there, right? It's the implementation of that we don't need to worry about. I actually really like heaps. They're probably like my favorite data structure, if I have one, but we don't need to get into it. The idea is that you throw in a bunch of numbers, and it'll either efficiently give you the maximum number or efficiently give you the minimum number, right? Yeah, the easiest way you could actually create that is you just simply like have an array that you're just sorting constantly, right? You insert and sort, insert and sort, insert and sort, right? Okay, so what we're going to do is iterate over every vertex in the graph, okay? And this is all setup. This is setup code. This is not in our algorithm quite yet, right? And what we do is we say that the distance response that we're returning, currently we don't know anything, so everything is infinity. And then for the previous path, we don't know anything either. And so basically all of our previous nodes understanding is basically nothing. We don't know. It's undefined. Another way of doing this is you just don't create these things yet at all, right? Like I think when we actually implement this, we're going to do the inverse of this, where our distance thing is just going to be some empty set.
Right.
And and then what we do is into the priority queue, we add nodes into the priority queue with a particular prioritization, which is infinity. So everything is equally bad up front, right? And what this priority queue is going to tell us is the next node that we should look at, right? So we talked about these, let's get this graphic here, these rings here, right? And we had this inner ring with, I think I did all like ones, right?
Yep. Yeah.
That means that the one that we wanted to pull out just had a rank of 1 and in that priority queue. And then we're going to exhaust all of those, right? After a certain point, we're going to iterate through all of those, and then we're just going to go to the next rank, which is going to be 2, right? Okay. So
actually this is running totally randomly. Like it is just optimizing paths between nodes however it feels like it.
Yeah, except that wait, what did I?
You're not quite on the right pseudocode. Using a priority queue.
Using a priority queue. Okay, yes. So we do actually know the distance for one node. So it's not random. We know the source. So that's going to have the highest rank, right?
There you go.
So that means while we iterate over the minimum, right? This is just basically an iterator just saying we're going to start to loop over all of our nodes. And while we haven't processed a node, we're going to just take the minimum distance one. And we actually created it because all you have in the beginning is the 0 distance one and then a bunch of infinities, right? So 0 is pretty good. Unless we put negative infinity in there, you can't get much better than that, right? So here's kind of like where the graph comes in, right? So we're saying, okay, give me all the neighbors of the thing that we're on right now, right? So the first iteration of this is just like the origin. And what we're going to say is that we're going to create some distance that we've calculated tentatively for this node V, right? Our tentative answer is that it is however long it took you to get to where you are currently, and since in the first iteration we're at the source, it's 0, right? Plus however long it takes to get from your current node to the one that you're looking at. And in this case, it's always going to be, well, it's not always going to be 1, right? If we start to go diagonals, it's going to be like the square root of 2, right? True. But if it is cardinal directions like you were suggesting, it's all just 1, right?
So I guess in this application, doing diagonal is actually not that difficult for us, is it? Because we just will actually be avoiding something that takes 2 to get there when it could get there in square root 2. So that's cool.
That is exactly right. Yeah. Okay. So what we do at this point is we store that and say, okay, that's what I think the best is. But what I'm actually going to do is I'm going to compare it to what I already have in my distance table, right? And if what I just calculated is less than what's in the distance table, then I've found the new best answer. And so this is actually, this whole kind of like, I'm calculating it now, I'm doing breadth first, I think I'm going to arrive at the best thing, but I don't actually know. This actually takes care of that for you, this little juke right here. And the reason why is you could imagine that you come to a point that could be approached from, let's say there are nodes on either side of the node that you're about to hit, and their paths leading to those nodes are exactly the same. They both have value 1. But to get to the node that you're targeting from one side costs 1, and to get to it from the other side costs 100, right? How did you know by the algorithm whether to go from the left or the right side? You don't really know at this point because the two leading up to it, those 2 neighbors have the exact same distance from the source, right? So this allows you to account for that situation here. However, once you've processed all of the nodes that have the same rank, you will, and then you will know all the minimum distances to all of the neighbors at that point, right? So this is the tricky part. You have to convince yourself that like once you've actually gone through this and you've done this thing, you are actually getting the best possible thing once you've processed it. Okay.
It's really this is the key step right here.
Yeah.
Well, both of these really, but yeah, that it makes
19 is the important one. 19 is the one that drives the algorithm. Prev actually doesn't. You don't use that to calculate the actual algorithm. All it is it just helps you get the actual path.
When I really like this diagram. Nope. Was it on here?
Are you talking about the?
Is it the first one?
Yeah.
Yeah, it's the first one where the actual lengths of the edges shorten as the algorithm goes. So like this thing that is 1408 actually becomes 11 as the algorithm runs.
Yeah, exactly.
So it collapses space essentially.
Yep, that's right. Right, because like going from 1 to 6 is 14, but that the algorithm just happened to hit that first. But then if you go from 1 to 3, and then 3 to 6, it'll become 11, right?
Yep.
Cool. Okay. So, oops, this is the one.
Not the priority queue, yeah.
Yeah. And then it's actually, we set the distance and then we also decrease the priority because we actually have to reshuffle stuff in our priority queue. Because we have recalculated the distance, this also needs to reflect the priority queue as well.
It's funny because I would call that increased priority, but I know it's a lower number for this.
Oh, right, yeah.
Yeah. It's Wikipedia's fake language.
Like improve its rank so that it sorts in front of everything. And then basically where you can stop, right? Like, you know how I said before, like this calculates everything? Mm-hmm. How do you know when to stop if you know what your destination is? Well, if you pull the destination on line 15 here out and you realize you've gotten there, you know that you have a minimum distance there. So that's when you can stop, is where you basically... so the important thing to do, though, is that you actually have two opportunities to check when to stop. You could either check to stop as soon as you hit the destination here, like if it happens to be a neighbor of a thing that you're processing, you could say if it's the destination, quit. But you can't actually do that.
That's not fully optimized. Yeah, you haven't examined all paths to the destination.
Yes, exactly. Or you don't even have to examine all of the paths to the destination, but you actually have to at least examine all of the minimal paths that you know about up to that point. Because you can imagine that, like, at a certain point, you can stop without having to worry about the path from behind the destination, right?
Yep, that makes sense.
So
cool.
Yeah. Okay. So that's Dijkstra's algorithm. I'm excited to actually implement it. It's going to be really cool, really fun. We are a little bit past the hour, so I guess we'll either have it working by next stream, or we should try to get it working by next stream.
I think we can do Dijkstra's by next stream, but if not, we'll maybe part of next stream we can write tests for it, see what testing it looks like, and actually watch it happen. So
yeah, totally.
It'll be a fun debug draw too. It'll actually be a very fun debug draw.
It'll be really sweet. Yeah. Nice.
Cool. Well, sorry for the technical difficulties.
No problem.
Twice. No, it's cool. Plug in the computer. That's next step.
Yeah.
All right.
Okay. Until Wednesday.
See you later, Jeff.